13.5 today, which is the law of sines. We've got two objectives for this lesson. One is to use the law of sines to find side lengths and angle measures of non-right triangles. And then we're also going to learn a method for determining area of a triangle without knowing the height. So first of all, here's the law of sines. Hopefully you recognize this. I think you should have seen it in geometry. And this first expression of the law, sine of A over A equals sine of B over B equals sine of C over C, is the one that I'm used to using, so that's the way you'll see me set it up. But you can also do side length over sine of the angle. The one thing that you absolutely need to make sure that you are doing correctly with law of sines is that this angle and this side are opposite one another in the triangle. So anytime you're setting up law of sines, you have to look for those angle side pairs that are opposite one another. So our first example, we're going to be solving for missing side length D. So I like to, when I start law of sines, the first thing that I look for is this angle side pair that are opposite one another, because that'll be my ratio without a variable. So I've got the sine of 68 over 3, and then my directions tell me to solve for D. So I look for the angle across from D, and I get the sine of 47 over D. So when my variable is in the denominator, I cross multiply to get it out of the denominator, and then divide both sides by the sine of 68. And D is about 2.366. Anytime you solve for a side length, I would like you to keep 3 decimal places. Our second example, we're simply told to solve the triangle. What solve the triangle means is find all missing pieces of information. So again, the first thing I'm looking for is this angle side pair that are opposite one another that we know. So I'm going to start by setting up the sine of 106 degrees over 3.6. And then I look for, I've only got one other piece of information. So the first thing that I need to solve for is angle P. So sine of angle P over the side opposite it, 1.5. Now my variable is in the numerator, so I'm not going to cross multiply on this one. I'm simply going to multiply both sides by 1.5. And then in order to undo the sine function and solve for P, I need to take the sine inverse of both sides. So what I do in order to avoid rounding error is I type the entire equation into my calculator exactly the way that you see it on my screen here. So make sure that you use parentheses where I have the parentheses. And then depending on how your calculator works, if it automatically comes up with parentheses after you type in the sign, make sure that you close that parenthesis before you hit your divide button to divide by 3.6. If you're not sure how to use your calculator to get this answer, then we can look at that in class tomorrow. So the answer that I got is about 23.6 degrees. So with angle measures, I'd like you to keep 1 decimal place. All right, so we have one piece of information. Knowing 2 of the angles in a triangle, instead of using law of sines to solve for the third angle, I'm just going to use that there's 180 degrees in the triangle. So I'm going to take 180 degrees minus the 106 degrees, that's angle M, and subtract the 23.6 degrees, that's angle P, and that gives me a 50.4 degree angle for the measured angle N. And now I have the angle opposite side N, so I can solve for that last piece of information. I'm going to stick with this ratio that I started with because I didn't round to set up that ratio, so I will not have additional rounding error when I solve for side length N. Because I did round when I solved for the measured angle P, which means my angle N has rounding error as well. This time my variable is in the denominator, so I'm going to cross multiply. And then I'm dividing both sides by the sine of 106. And I get about 2.886 for my side length N. All right, so that's law of sines. Next, we're going to take a look at the new formula for the area of a triangle. So this one, notice how it says given side angle side. Of course, the first formula is the area formula you learned in geometry. What this given side angle side means is, think back to that triangle where we had triangle ABC, little a, little b, little c. Side angle side information would be if I knew sides B and C and angle A. So those are the two sides and the included angle. And then I can use this formula. All right, so looking at my triangle here, I have two angles and two sides. Well, perfect, I need two sides in order to use my area formula. But the angle that I needs to be the included angle, meaning the angle formed by the two sides that I know. If we look at our picture, that's the one angle that I don't know. So again, using 180 degrees in a triangle, I'm going to solve for that missing angle. Oops. I keep typing 108, which is not helpful. So I'm getting 60 degrees. All right, so now all I do is substitute into my formula. The two sides, so 120 and 132, times the sine of the included angle. So our area is about 6,900.490 square meters. So make sure you're labeling your answer anytime that you have units that you're given. All right, the last piece we're going to look at is applications of the law of sines, meaning word problems, everybody's favorite. All right, so we've got this bike race. It's following a triangular shaped trail. So I'm going to draw the picture as I read. So the first leg is a straight 6-kilometer ride. After that, the biker turns 283 degrees to the left. Let me move my label here. And follows the trail to the next turn. Turning 269 degrees, the biker ends where they started. How long is the entire race? So obviously the first thing that we need to do is find the measure of the angle inside the triangle. Well, the exterior angle is a total of 360 degrees. So if we take 360 minus 283 degrees, that gives me a 77 degree angle inside the triangle. Same for my next turn, 360 minus 269 gives me a 91 degree angle inside the triangle. So what we need to do in order to answer the length of the entire race is to find the two missing sides. So we'll just call these sides X and Y. So the first thing that I do using law of sines is find those angle side pairs that are opposite one another. So I've got my 91 degree angle opposite my 6-kilometer side. So I've got the sine of 91 over 6 equals, and I can choose to solve for X or Y first. Since I haven't yet found my first angle, I'll solve for Y. So we've got the sine of 77 over Y. My variable is in the denominator, so I'm going to cross multiply. And then divide by the sine of 91. For an approximate length of 5.847. So in order to solve for X, I need to know what the angle across from it is. So I'm going to subtract my two angles from 180, and that gives me a 12 degree angle. So setting up my second function, I'm going to have again the sine of 91 over 6, because that has no rounding error, equals the sine of 12 over x. So again, cross multiplying. And then dividing by the sine of 91 again. The last leg of the race was about 1.248 kilometers for a total of so the total race was about 13.095 kilometers, adding up all three sides. All right, last example. The angle of elevation to the top of a building is 21 degrees. So here's my building. It said at a point 80 feet closer. So as I walk 80 feet closer and look to the top of the building, my next angle of elevation is 33 degrees. Approximate the height of the building. So this one is a two-step problem. When I look at this, the first thing that I notice is I can find the measure of this angle by using linear pairs. Remember, linear pairs are supplementary. So I'm going to subtract 33 from 180, and that gives me 147 degrees. So now I have two angles and a side in the one triangle. So I can find that third angle, again, by subtracting from 180 to get the angle across from the side that I know, my 80 feet. So what I'm looking for is this side length so that I have enough information in that second triangle to solve for the height of the building. So I'm going to set up my law of sines. The first angle side pair that I see is the sine of 12 over 80. And I want the angle that's across from x, which is 21 degrees. Again, cross multiplying. And dividing by the sine of 12. We get about 137.892 feet. Okay, so now looking in my second triangle, my right triangle here, I can now use SOHCAHTOA to solve for B. So I know that my hypotenuse is about 137, almost 138 feet, and I need the side opposite. So I'm going to use sine of 33 equals opposite the height of the building over the hypotenuse. I'm going to multiply both sides by 137.892. And the height of the building is about 75.101 feet. So here's the assignment, and we will see you in class tomorrow.